Hi, welcome again to your YouTube class, Electronics Class Tanzania, your favorite YouTube class which will learn about electronics. Today we are in lesson 3, but before we continue with lesson 3, which will be about transistors, let's take a few minutes to recap about lesson 2. In lesson 2, we learned about Ohm's law and diodes. Ohm's law is the relationship between the three parameters, which are voltage, current, and resistance. We'll see later in a triangle of Ohm's law. I will show you. In a algebra form is equal to voltage times current times resistance. Ohm's law is very useful in calculating those parameters in electrical circuits. Also, in lesson 2, we learned about diode. Diode is also a very useful device in electronics circuit and application. Diode generally is a semiconductor device which allows current to flow in one direction. And it's made of two types of materials, which are P material and N material. It's a PN, and which normally P is positive and N is negative. P, which is called positive, which is anode, and a negative, which is N, is cathode. We'll continue with recap on Ohm's law. Ohm's law can be shown as a Ohm's law triangle. We have Ohm's law triangle, which we have volts here, we have current here, and we have a resistor here. In a simple algebra, we have learned in lesson 2 that voltage is the relationship between current and resistance. So when we take voltage is constant, voltage when is constant, the relation with current is that when you increase the current, the voltage should be small. And when you increase the resistance, the current goes down. So this is the relationship between current, resistance, and voltage in regard to Ohm's law. Ohm's law is very useful in electrical circuits. We'll see it, and also in engineering, in electrical engineering in general, we'll be using Ohm's law in finding is a resistance, current, or voltage. Let's continue with part 2, which was diode. As a recap, diode. Diode is a semiconductor switch. Is a semiconductor device which acts as a switch, and diode has a property of only allowing the current to flow in one direction. And a diode is made of two types of material, which is P and N materials. P is positive, which is anode, and N is negative, which is cathode. So the current will flow from P to N. Of course, the current can flow also in the reverse direction, but you have to apply a very high voltage, which is not in a application is not used like that, because any semiconductor material can be a conductor when you apply a very high voltage, but it will be some sort of distraction. So in a normal application is from positive side to negative side. Let's see, this is our PN diode. Here will be positive, here will be negative. Here is anode, and here is cathode. So this is our, and the current will flow in this direction, PN. Let's continue with diode as a switch. Diode. We have seen that diode is a semiconductor device which allows the current to flow in one direction.
So we can have our diode here, and we are saying this is our switch. The current flow from high potential, let's say this is 6 volts. The current flows from high potential to low potential. This is current. Since the flow of the current is in line with the arrow of the diode, the switch will be on. But if the diode is like this one, we reverse it. This is our arrow. Let's say we have 7 volts plus here, 7 volts. Here the ground is a 0 volt, 0 potential, 0 potential. The current normally is flowing from high potential to low potential. This is our diode. This arrow is the current flowing from high potential to low potential. Because the arrow is in a reverse, the switch will be off. The current will not flow. But if we have a mode like this one, let's say we have minus 8 volts, and we have our diode here. Diode is an arrow. We have our diode here. This is 0 potential. 0 potential. This is our diode here. The current normally flows from high potential to low potential. 0 volts is high compared to minus 8. So the current will flow in this direction from high potential to low potential. This will be a flow of current, and this our switch, which is diode, will be on because in line with an arrow of the diode. Because in a diode, here is P and here is N. Here is positive, here is negative. Yeah, let's continue with our electronics class in lesson 3. Lesson 3, we are going to learn about transistors. Transistors. What is a transistor? A transistor is also a semiconductor device, but it's made of two types of material. Is diode, but it's a combination of 2 diodes. Before transistors in electronics, they were using vacuum tubes. But since the invention of transistors, there are much development. The problem of vacuum tubes were larger, but also heating, and also you have to warm. In contrary to transistors, they are very light, rugged, and they are small. So it's a big invention in transistors. So transistors are of 2 types. We have NPN transistor and PNP transistor. NPN transistor, we have P's in a center. So P is sandwiched by N, and N in each side. And also PNP transistor, N is sandwiched by P and P type of materials. And the application of the transistor is used as an electronic switch, and it's a very fast switch. For instance, in a smartphone we are using today, there are more than 2 billion transistors there. So it's very useful and in its development. Also, transistors can be used as an amplifier, as amplifying small signal to much larger signals. So let's see the electrical symbols and the representation of a transistor. As I said, we have 2 types of transistors. We have NPN and PNP. Let's see NPN transistor. So NPN transistor is drawn in this way. The base is with small width. So it is NPN, Here is small width. Here we have a base which have small widths. Here you have emitter current. Of course, we have a collector current here. Also, we have a base current here. This transistors, another name is bipolar junction. It's called bipolar junction because all the electrons and the holes are flowing. So it's a bipolar. Another name is bipolar junction transistors. The electrical symbol of the transistor NPN, we have a cycle here. In NPN, the arrow is going outward. So you have your base current here. You have your emitter current here. You have your collector current here. The current is flowing outwards, and also we can represent NPN transistor by using diode. P is in a positive direction, in a positive. So this is our arrow, which is our diode. And also here is our arrow, which is our diode. So NPN transistor is like two diodes connected back to back, because this is P, this is N, this is N. It's like two diodes connected back to back. Okay, let's see about PNP. This is first type, and the second type is PNP. As usual, the base is with small width, which is P here. Which N. Here are N. Here are P, and here are P. Let's say this is N here. Yeah, this N. Our base here. Sorry. Our base here. Our base current here. Our emitter current is usual here. Our collector current is here. So we can show electrical representation of PNP in this one. Our cycle as usual. We have our emitter here. We have our collector here. The current is flowing towards the transistor. This is P and P. The current, the emitter current is flowing towards the transistor, and the ground is in a collector side. So, and in NPN, the ground is in emitter side. So this is a representation of PNP, but also we can put it PNP. We can show PNP by using two diodes. Our arrow here is a diode, and here is P. Here our N. Also P here. So also this is a representation of PNP transistor. Is two diodes being put by connecting N on each side, and here is positive, negative, positive, negative. So this is a PNP transistor. Let's see the relation of this is NPN transistor. We start by a cycle. And then we have our emitter here. We have our IC collector current. We have our emitter current here. And we have our base current here. This is an NPN transistor. The arrow is going outward. So let's see the relationship of emitter current with a collector and base current. This formula is very important. In NPN transistor, the emitter current, which is this one, emitter current is this one. This is ground, This is ground, So this is emitter current, shown here, IE. Emitter current is the summation of collector current. Let's put here to be more clear. This is a collector current plus this is a base, IB, plus base current. We have an emitter and emitter current. A collector current, a formula is beta IB. So normally our beta can be 100. Let's here put 200. This is a factor. So if we want to know emitter current in this formula is IC, which is beta IB plus IB. And here we have IB. We put IB outside the bracket. IB outside the bracket, we have beta plus 1 here. Then we'll have, now we are looking for IC. So let's take IB as 50 microampere. This is your IB. IB is 50 microampere. So our IC here, from the first formula, IC beta IB. So our beta is 200, and our IB is 50 microampere. So we are going to have 10,000. This will be 10,000 microampere. So it's equivalent to 10 milliampere. It's equivalent to 10 to 10 milliampere. So in our formula, here IE is equal IC plus IB. So we have IB, we have IC. So our IE is equal to 50 microampere plus 10,000 microampere. So here we have 10,000 and 50 microampere, which is equivalent to 10.05 milliampere, because I just divide by 1,000. So it's 10.05 milliampere. This is the IE. So here is a relationship between IC, IB, and IE, and the formula is this one. IE is equal to IC plus IB. This is for NPN transistor. And our beta, IC current here is beta times IB. And the beta is this factor 200. So we have our IC here. We have our IC here. So IE again is IC plus IB. We have our IB. We have our IC plus IB is 50 microampere. Then we have our value. So this is a relationship between IC current, IB current, and IE current in a NPN transistor. And mind it that in NPN the arrow is going outward, so that it's an NPN transistor. Thank you for watching lesson 3 of electronics class Tanzania. We have seen a recap of lesson 2, and also in lesson 3 we learned about transistors. We have seen transistors is very useful in electronic and has bring a lot of changes, because before we are using vacuum tubes, but now transistor which is light, rugged, and small. Transistor is a semiconductor device which can be used as an electronic switch, a very fast electronic switch, also as an amplifier. We'll continue learning about transistors also in lesson 4, because we just started at the basics, but we'll also continue with the basics of transistors, because the transistor is very wide, and we'll see how we can find the calculations of have an amplifier, etc., etc. So don't forget to subscribe, like, and share Electronics Class Tanzania so many can learn electronics. Thank you for watching.